Hi, it's Miss Redican here. And I know some people were confused a little bit about the data yesterday in the lab. And I just want to maybe clarify and go a little bit further. It's not about math, it's really just about patterns. So let's take a quick look at some of the patterns that you looked at yesterday in the lab and that you'll be looking at again today. Okay, first pattern is pH. pH is a measure of H plus, okay, or how acidic something is. And you should have seen that there's a relationship between pH and H plus. This is an exponential, they call it a logarithmic relationship. So the pH is 1, the H plus is 1 times 10 to the negative 1. pH is 2, 1 times 10 to the negative 2, and so on and so on. Another pattern you should have learned is that there's a relationship between pH and pOH. They have to add up to 14. So let's look. If the pH is 1, the pOH is 13. 1 plus 13 make 14. That checks out. Try one more. Go down here to pH 7. pH 7, the pOH is also 7. 7 and 7 make 14. It checks out. Okay, so let's take a look at some other patterns here. So pH 1 is 1 times 10 to the negative 1. Basically, you're taking your pH number and you're making it a negative exponent to the 10th power. What does that look like, though, in real numbers or decimal notation? 1 times 10 to the negative 1 is 0.1, which is like a dime, 10 cents. pH of 2, 1 times 10 to the negative 2, which in decimal notation is 0.01, which is like a penny. Halfway between a penny and a dime would be a nickel. So this is where things might have gotten a little confusing, and yesterday you learned a simplification, and that was fine. But let's backtrack and really look a little bit deeper. So, halfway between a penny and a dime we know is a nickel in real life in decimal notation. Halfway between pH of 2 and a pH of 1 would be 1.5. Now, yesterday when you saw decimals, we took the decimal and we rose it to the power of 10. So 1 times 10. Okay, sorry about that. Let's get out of that format. 1 times 10 is negative 1.5. And again, you learned yesterday, you can highlight, format, text, and superscript. Okay, so that's a clear pattern, right? We take the pH and we raise it 1 times 10 to the negative that power. However, mathematically speaking, 1 times 10 to the negative 1.5, that's not really a correct way of writing. So let's take a step further. Okay, so let's get back to 0.05. How would you write that in scientific notation? Well, it would be 5 times 10 to the negative 2 power. Right? And again, we can take that to the exponent, format, text, superscript. So, 0.05, or a nickel, in scientific notation, is 5 times 10 to the negative 2. So you can see that, right? Yesterday you wrote a simplified version, 1 times 10 to the negative 1.5. Mathematically, it's not really correct. So I just wanted to show you the real correct way of doing this. And notice, now the pattern, whenever there's a decimal, the pattern is less obvious. That's okay. For those of you going on to college chemistry, you'll learn, or AP chemistry, you'll learn a little more in depth about the decimals. We're looking at patterns here. That's the main thing I want you to take home. Let's recap the patterns again. pH is measuring how much H, or hydrogen ions, how acidic something is. A pH of 1 is 1 times 10 to the negative 1. The other pattern is that pH and pOH have to add up to 14. A last pattern is that there's a similar relationship between POH and how much hydroxide or OH is in there. Again, you can take that whole number, POH of 13, and the concentration of OH would be 1 times 10 to the negative 13. And that pattern lies true. Okay, hope that cleared some things up and went a little bit further. That's all.